Hello and welcome to the Hudson and Thames lecture on data structures. My name is Valeriia Pervushyna and today I'm going to be your speaker. I'm a quantitative researcher at Hudson and Thames as well as Masters in Quantitative Finance at the University of Warsaw. If you're going to have any questions at the end of the lecture or you just want to reach out, my Twitter handle is listed down below. I'll be glad to answer all of your questions. So what are we going to be talking about in this lecture? Today, we're going to be discussing the importance of financial data types, data bars, and role of financial microstructures, as well as diving a bit deeper into what types of financial microstructures they are and how to construct them, such as standard or information-driven bars, as well as tips, tricks, and conclusions that we came up with during the research to create this lecture. Also, all the references to the sources that we use for creating this presentation will be listed in the corresponding reference slide at the end. So let's start. The key inspiration for this lecture would be the book by Marcus Lopez de Prado, Advances in Financial Machine Learning, especially the second chapter on data structures. It's very hard to overestimate the importance and the impact that Marcus Lopez de Prado had on the quantitative field. He has helped modernize the finance for the past 20 years by advancing the adoption of machine learning and supercomputing. And while we're talking about machine learning and creation of the machine learning algorithms, the first thing that comes to mind of every researcher, it is what type of data to use. As the data can make or break the situation, it can lead you to your greatest discovery or make you fail miserably if you choose it wrongly. Actually, the raw unprocessed data sets are usually the best starting point and are behind any significant discovery in the quant world. As Marcus Lopez de Prado once said, the data that is hard to store, manipulate, and operate is always the most promising. So it's important to understand the categorical difference in financial data that it has within itself as the approaches, and let's be honest, the discovery opportunities greatly differ across the mentioned categories of raw financial data. So what are the four essential data types that financial data is actually categorized in? The first would be the fundamental data, the second is the market data, third is analytics, and fourth is alternative data. We order this in such way by their diversity from least to greatest. Financial data comes in many shapes and forms. I would like to discuss it in a bit more depth of the pros and cons of using one or the other. So let's start with fundamental data, the most accessible of the bunch. Every 10K report, this is the perfect source for your fundamental data. Assets, liabilities, income statements, cash flows, everything is there. However, with the ease of access comes the unlikely nature of existence of any unexploited value there, as everybody else also has the access to the data and already probably found any unexploited value that you could find. Also, not to mention, this type of data has very low latency and usually is backfilled, that is making it less than ideal for application to ML research. But it still may prove useful if used in combination with other more diverse data types like market data, alternative data, or analytics. Moving on to market data. Market data is anything that is happening on the exchange that is recorded that's connected to trades. For example, fixed messages. Fixed messages allows you to virtually reconstruct the order book from scratch. Bids won in competition. All of these messages, all of this data is enormous actually in their quantity. Every day the exchange generates tens of terabytes of financial data. Well, it makes it mostly very hard to process, even harder to store. But as we said before, it is the data that is harder to handle that we will find our insights in, that we can find our significant features. For example, as a hint to where some interesting findings can be is that every type of market player, every type of algorithm has its own footprint that is recorded in the order book. So market data is the exact place that you could exploit this knowledge at, and actually it makes for very interesting strategy research. The third type of data we're going to be discussing is analytics. Analytics is the data based on an original source, like fundamental data, market data, alternative data, or even other analytics. The best part about the analytics that it's already pre-processed and given you on a silver platter. You are given either features or core, most important data to enhance your model. For example, you can get the sentient signals from alternative data like social media posts, or strategy signals from market data. But with its own pros, it comes its own cons. The cons being first that this data is usually rather pricey and not very accessible. Also, even when it's accessible, it's usually you're not the unique sole proprietor of this data, and other people also have the access to the same type of processed data. But today, the biggest drawback of the analytics is, as it's a processed data, it incorporates the bias of the other people aside from you who were processing the data. So it can kind of influence your research in a way that you wouldn't do it yourself. And next, last but not least, would be the alternative data, the truly unique data sets of the 4 types. This can be anything. An alternative data can be anything from records of tanker movements to traffic lights schedules to social media posts, as we mentioned before. Anything can be an alternative data set. The important part is how would you work with it, how would you store it, and what features would you extract. And here comes the biggest drawback of using alternative data is the logistics, and how much time does it consume to transform it into an informative feature. This is probably the reason why most companies are avoiding to use the alternative data, but sometimes it can be the biggest competitive advantage if you manage to make it work for you. So this is definitely one of the most, it's like a Klondike for unique and very, very successful ideas, but at the same time, it takes a long time to discover them. So we've talked about the raw data, but unfortunately, we cannot actually apply ML algorithms on the raw data and expect everything to work. No, first the researcher needs to parse the data, extract valuable information from it, and store those extractions in a regularized format. So here, when data bars come into play, actually in finance, the table rows of the extracted structures in ordered data are referenced as data bars, and hence the name. So the information collected usually includes timestamps, volume by weighted average prices, open, close prices, high-low prices, volume traded, and other indices. The data bars are the regularized versions of our data that allows you to extract more information from your raw data that you would do otherwise. And even within the data bars, we have our own classification. We can divide it into 2 key types. First, it would be the standard bars that are sampling the data based on some type of index threshold. For example, it can be time, tick, volume, or dollar bars. And information bar, so they are sampling at when the threshold for some type of information influx, like imbalance on run informations, will be surpassed. We'll be talking about those different types in more detail further on in the lecture. And we're going to start with standard bars. Standard bars are most commonly used in the field, and among those most commonly used, the most popular would be the time bars, and also the more easily accessible for people's understanding. So they are obtained by sampling information at a fixed time intervals, for example, every 5 minutes or every minute, if you wish to do so. However, to quote Marcus Lopez de Prado again, although the time bars are the most popular among practitioners, they generally should be avoided because they often exhibit poor statistical properties like serial correlation, heteroscedasticity, and non-normality of returns, which is less than ideal in case of machine learning. Algorithms. So what's the alternative, we say? One of the three alternatives is the tick bars. Tick bars are obtained by sampling information each time a predefined number of transactions takes place. For example, every 5,000 ticks. Multiple studies have confirmed that sampling as a function of trading activity specifically allows us to achieve results and returns closer to IID Gaussian distribution, as mentioned in Mandelbrot and Taylor as early as 1967, and in Jiman and 2000s, and many more. However, working with the tick bars, you need to be aware of the outliers associated with them. For example, in some exchanges, at the opening and close of the market, the auction trades are performed. And sometimes while this auction trade can be worth thousands of ticks, it can be recorded as one ticks, bringing in this instability and outliers that we're talking about. The next two types of bars would be the volume and dollar bars. We'll start with the volume first. They're obtained by sampling every time a predefined amount of the securities units have been exchanged, for example, every 5,000 units. Sampling as a function of volume achieves even better statistical properties, as we said, closer to the Gaussian distribution. And to dive a bit deeper and to understand more about this time-independent sampling, I would like to recommend you checking out the volume clock insights into the high frequency paradigm paper by Marcus Lopez de Prado. Also, talking about the next type of bar, the dollar bar, is similarly obtained by sampling an observation every time the predefined market value is exchanged, for example, every $5,000. But it makes more sense because the number of shares traded is a function of actual value exchange. So if we're sampling the bars in terms of dollar value exchange rather than ticks of values, it makes much sense, and especially because it makes the obtained data unbiased to the fluctuations in the overall number of outstanding shares that was changing during the years, and you have the ability to make the observations even more robust if you use a dynamically adjusted threshold. And personally, me and my colleagues would recommend using dollar bars in your future research, but more on that later. As a conclusion to the description and talking about different standard bars, I'd like to show you the visualization of the comparison of different sampling processes results using a volume tick, dollar clock, or a regular time clock, which is basically the same as using volume tick, dollar, time bars, compared to the normal distribution. As you can see here, the normal distribution is the dashed line, while the time-based distribution is the red line. You can clearly see how far from normal it is. It has the most outliers. It has the least normal function out of all, the closeness to the normal function out of all of mentioned here. The volume tick and dollar clock has a comparable results, and I think by changing the frequency, the different volume tick or dollar bars and sample, you can kind of have an interchangeable result, but they are incomparably closer to normal, to Gaussian distribution than the time-based clock that supports our claims, theoretical claims about the performance of the said bars in the ML research. So we finished with the standard bars, and right now we can move on to the information bars. Information bars is a more complex concept compared to the regular bars, but they're nothing too complicated. The imbalance bars is the first of the two we're going to be talking about. And the ideas of the imbalance bars is to sample more frequently when the imbalance in certain index tick, volume, or dollar exceeds our expectation. By synchronizing the sampling with the arrival of informed traders, we may be able to make decisions before prices reach a new equilibrium level. For example, let's talk about the tick imbalance bars. The idea behind tick imbalance bars is to sample bars whenever tick imbalances exceed our expectations. So as we can see in this formula, when the theta, this is a cumulative sum of tick direction multiplied by the volume of the trade, exceeds our expected imbalance threshold, we chose to sample our data set. In fact, we can understand the tick imbalance bars as buckets of trades containing equal amounts of information regardless of volumes, prices, or ticks traded. Well, dollar and volume imbalance bars are basically the same as tick imbalance bars, but their definition are extended to imbalance or volume, imbalance to volumes and dollars exchange respectively. Then we should be talking about the run bars. The purpose of run bars is to sample more frequently, but not when the flow imbalances change, but the sequence of buys diverges from our expectations. So when the large traders sweep the order books or use iceberg orders, all of it leaves trace of runs in buy sequence and an order book. So for these reasons, it can be very useful to monitor the exact sequence of buys in the overall volume and take samples when the sequence diverges from our expectations. The mathematical definition is very similar to what we had in tick imbalance bars, with the imbalance flow changed up to the sequence of runs. And again, similarly to imbalance bars, the dollar or volume run bars are the extension of the definition of tick run bars to dollar and volumes, respectively. We've talked about our data bars right now, and what is left to talk about is the tips, tricks, and conclusions that we've came up during the research and numerous years of working with the financial data within our company. So let's start with the tips. Based on real-life trials, we've came up with 3 major tips I would like to share with you. First one being that we highly recommend using dollar bars, as they tend to have the best performance in comparison to standard Hudson parts. The second tip being the sampling guideline to follow with the dollar bars is for sampling process to be performed around 50 times a day. And this is empirically found best type of sampling frequency. And also the last but not least tip would be proposed by Marcus Lopez de Prada in his doctoral thesis, is that sometimes working with tick data is too costly in both financial and computational senses. So to reduce those costs, it is possible to utilize the 1-minute data as a substitute for constructing market microstructural features in different data bars. And as what's even more important, in his doctoral thesis, Marcus Lopez de Prado claims that it exhibits even better statistical properties than the microstructural features, hence data bars created from the tick data. So it's a very interesting concept to test out, and I would highly recommend you to try out these ticks in your own research. Moving on to the tricks. When dealing with products that are given non-constant coupons, dividend, or dependent on corporate action, it's very hard to avoid structural break. So to deal with such situation, there are a few tricks that can be applied. First being ETF tricks. It models a basket of very different securities as if it was a single cash product from a given history of bars. The second tip would be to perform a single futures role when working with the futures to avoid the structural break that come along with switching from one futures contract onto the other when the expiry date hits. So, how it works is it forms a time series of cumulative roll gaps and basically detracts that gap series from the price series, leaving you with one consecutive correct price series for the future. The last but not least is the PC8 weights. While computing a hedging vector might be hard and it is hard to know where to find the intuition, our suggestion would be, and also Marcus Lopez-Duprado's suggestion, would be to compute the vector of allocation that conforms to a particular distribution of risks across covariance matrix principal component. The description for every of those three procedures can be found in the Advances in Machine Learning at the end of the chapter 2. And again, we highly encourage you to test this all on your own. So what's the conclusion of our today's lecture? The only way to achieve any substantial discovery in the process of financial research is to utilize an unstructured and raw data set. However, actually extracting the useful features is very hard, and we need a method to the chaos. The data structures is an efficient and effective way of creating the data set that is much more robust and informative compared to widely used time-dependent data, and that can play a key difference in the success of your research. If you wish to apply all the techniques and algorithms that I mentioned today, you can check out the MlFinLab that has every algorithm that I mentioned already implemented and ready to use. Bring the power to your trading using a MlFinLab, as it is a collection of production-ready algorithms from the best journals and graduate-level textbooks packed into a Python library that enables portfolio managers and traders who want to leverage the power of machine learning by providing reproducible, interpretable, and easy-to-use tools. All the references that you wanted to maybe search for are here on the 21st page of the presentation that will be available in the description down below. I highly recommend you to check the books that are mentioned here for your own to maybe satisfy your own curiosity and maybe find some more insights for your future machine learning research and algorithms. I thank you very much for your attention, and for more information, please subscribe to our YouTube channel. I was glad to see you today. Bye-bye.